Okay, so this is joint work between myself and Nicola. This is work that Nicola did when he was visiting us at RMIT, and the work was supported by the ADMS Research Center down with us in Australia. So look, you know, what a great start to the conference. The Salton Award winner is an evaluation god of our field, and you know, we do evaluation. We love evaluation. We have a whole bunch of things that indicate that our evaluation is done very well. We have a whole range of different evaluation exercises from around the world. We have a series we have inventive evaluation measures that other fields use. NDCG can be found all over the place. And then we have people like Norbert Fuhrer, Tetsuya Sakai, always reminding us to do our evaluation more effectively. Something that Ellen actually said in her talk, which I think is a little bit sort of not always remembered about one of our legacies, and it's great that she mentioned this herself, is this large collection of structured data which each of the evaluation communities have created. This set of runs, and this set of runs enables us to run a whole bunch of experiments in information retrieval. To take one of those runs, one of that set of runs in Trek 13, in the robust track, there's about 110 runs submitted. You can calculate the mean average precision of them and lay them out like this. As Ellen was hinting in her talk, a whole bunch of people have done research using these run data sets. And indeed, they all use a fairly consistent methodology. When Nicola and I started writing this paper, we only cite some of those early papers, but subsequently we've come to realize that it really is a methodology that continues. So Jimmy Lin has a paper on arXiv from 2024, and I saw 2 papers at ICTIR on Saturday that were using this methodology as well. And by and large, this methodology, which I'll tell you about in a moment, says that the test collections we have are working pretty well. What do we do? Well, you take that set of runs and you throw it into a scatter plot. And the scatter plot will be something that has some sort of comparison between an official measure and some modified measure. So what might that mean? It might be, for example, you take a topic subset, try the runs out on one topic subset, and then compare it against runs on the other topic subset. Or maybe, as Ellen said in her talk, maybe you have one set of human assessors and you compare it to another set of human assessors. Maybe these days it's a human assessor versus a large language model doing some relevance labeling. But by and large, you get these comparisons that are done this way, looking across all of the runs for a particular track of Trek or Clay or NT-SIGIR, pick your favorite. Sometimes people will do things like some sort of correlation measure, like Kendall's tau or Spearman or something like that. Other people will do pairwise comparison. So what Nicola and I are going to do in our paper here is we're going to pick out pairs of runs, and we're going to say, hey, this pair of runs looks like the top one is doing better on the bottom measure. Is it also doing better on the measure on the y-axis? And if we get if it seems to be the case, then that's a tick. And you can go and sort of do like all the different possible pairwise combinations and come up with some sort of averaged score overall. And by the way, if you don't believe me about this correlation thing, did you see that picture from Ellen's talk earlier? It's absolutely what people do. Interesting question, though. What all of these papers have done, all of these papers, by and large, are doing is saying, how do we do on correlating all of the runs that are submitted to a collection? What we mostly do at SIGIR is we take a very small number of runs, which are often operating at the state of the art, and we're changing an IR system by small amounts, and then calculating scores. And so the question that Nicola and I wanted to ask is, how well do our test collections do when we only consider a limited number of runs from a retrieval experiment, the kind of thing you typically see at a SIGIR conference? Maybe we've got a pair of runs, and maybe in this, hypothetical example, this pair of runs, while it's doing very well on one of the measures, there's no big difference on the other measure. So what do we do? That sounds like a little bit of a problem. I mean, I'm a lover of exploiting the run data, and I've come to know it over the years because really of the sort of the care and thought that Ellen and Chris and others have put into this. When you look at this set of runs that you get from something like Trek 13, there aren't 110 runs. There aren't 110 separate groups submitting runs. There's actually about 13 groups in this case, each submitting groups of runs. And you can identify those very easily. There's a prefix in the run name. And what we speculated was that it might be possible to pick out each of those groups of runs from each of the groups, and does that grouping give you an approximation of a sort of a typical SIGIR experiment? Most experiments involve people comparing variations of their own system against other variations of their own system. It's very rare to see a SIGIR paper where someone is comparing their system to 10 other separate systems. They tend to compare it to one or two state-of-the-art baselines and then variations of their system. So what we decided to do was, instead of taking all of those runs in a oneer, what we decided to do was to run the same kinds of experiments that we've seen in the past, but do it on a participant-by-participant basis. So do the calculations for these runs. I think I've got one more animation. No, do this for the runs here. Do it for this particular participant, and then do it for each of the other 12 participants in the submission, and then take some averages. So we're comparing what we were calling track runs, which is the standard way of doing this, with what we call participant runs, where you group by participant and then work that way. What am I trying to say here? Oh yeah, and here we're going to look at the topic subsets as our way of splitting. We're going to look at three aspects in the paper. We're going to ask ourselves about significance tests. I quoted Norbert earlier because I wanted to actually put some numbers on something that Norbert has been talking about many times, about multiple corrections for multiple testing. We're going to look at the generalizability of significance tests, and then we're going to talk a little bit about what we can do about some of the problems that we find. When we talk about corrections for multiple testing, this is a screenshot from an old SIGIR paper from myself from a few years ago. We know what happens. You produce this table of results, you absolutely bombard it with t-tests, you run a whole bunch of different tests, and of course, there's a huge risk of false positives when you're doing that kind of testing. So there are standard ways of correcting for this. There's the Bonferroni, there's the Tukey correction, and what we wanted to do, although it's well understood that doing multiple tests will cause problems, we wanted to put some numbers on how big a problem that was. We ran this across three collections, the one I've already mentioned, plus two others. And this table tells you, gives you a little bit of an oversight about what we observed. So when you do all those comparisons for those 110 runs and do each of those pairwise comparisons in the conventional trackwise approach, there's about 6,000 pairs. Nearly 5,000 of them come up as significant on a t-test. But when you run some sort of correction, that falls from about that down to about that, which means that somewhere in the region of about 30% of the significances that you're seeing are probably false positives. Surprisingly for us, and we can maybe talk about this if someone wants to ask later, there wasn't much difference when you run this as the track or as the participant version. But the other differences that we did notice on Trek 26 and 27 was that this risk of false positives, these so-called type 1 errors, is actually quite high, maybe 60%, maybe 40%, depending on the type of correction that you're using. We speculated that this might be because these collections have fewer topics. So we took the Trek 13 robust collection. We've been using this because it has so many topics in it, and we ran these experiments, but using different subsets of topics of different size. And here we see that this failing to correct for multiple testing means that you run the risk of having a very large number of false positives. This is something that plenty of people have said would be true. We just wanted to put some numbers on this. The other thing we wanted to study was this question about the generalizability of a test. So if you observe a significant difference, let's imagine this run and this run, there's a significant difference between them. If you get a significant difference, the first thing you do is submit that difference to a publication, because when you get a significant difference, you've got a good chance of getting published. So there's an interesting question about whether there's always a risk of having what's known as publication bias. Do we tend to publish the papers that have significant results? So you can do a kind of an estimate of publication bias by saying, well, if I got significance here, and then I run it on the other metric, the other way of measuring, do I also get significance? And if the answer is no, then there's a risk of bias. So in the paper, we talk about this bias measure that looks at the number of times you observe significance, maybe using one topic subset, and then looking to see whether you observe it on the other topic subset. And so we ran some tests, but using the track and the participant runs. Now here, when you sort of do the traditional method, which is using the track approach, you don't get too high a bias. But when you do the participant approach, this risk of bias appears to be very high. And we can dwell on that a little bit longer, again in the questions, but say if you have a collection of 50 topics and you observe a significant difference within just the participant runs, you're unlikely to see that significant difference repeated on a different topic subset. This effect goes away as the topics grow, topic set sizes grow, but it's still quite high. Now, I won't have much time because the flag's just been waved, but we do describe methods for looking at pairs of runs, and essentially through a resampling process, resampling topics multiple times, you can come up with some probabilities of estimating the likelihood of there being problems or not there being problems. But I'll finish, I'll take my colleagues' a warning about time and just sort of say that we've got a few conclusions in this piece of work. So we've got conclusions for authors, for SIGIR authors. Norbert, I hope you're happy. We wanted to just sort of say that using multiple corrections for multiple testing is critically important. We're really quite concerned about the number of potential false positives that we're observing. And we've also provided on that previous slide a way in which you can analyze the run pairs to help you resample topics. But for evaluation nerds, and I can see one or two of them in the room here, the things that what we've done here is we've suggested that there's a different way of benchmarking test collections, where you focus on this idea of participant runs. I nearly snapped another picture from Ellen's talk, actually, where at the very end she was talking about LLMs and showed that the manual runs didn't work. You know, if you take the entire track, it's still looking okay, but then there was those funky runs at the end. So looking at groups of runs looks like an interesting thing to do. What we've proposed is to look at groups of runs grouped by participant, but Ellen has done a very nice thing of saying grouped by some other process, perhaps, for example, manual runs. We think this is perhaps a more realistic way of benchmarking collections than what's been done in the past. And then collectively, although Ellen was also saying this in her talk, we need to think about whether we can make test collections more reliable, because we're quite concerned about this bias issue that we identified. I can see the colors on this projector are a little bit funky, so I don't know how this will work out. I just wanted to sort of finish as well by showing you something that my colleague Damiano Spina created this year, which is an indigenous painting that he commissioned called Information Retrieval on Country. It illustrates algorithms, which are these blue clouds floating over country. Those algorithms either kind of ignore country, sometimes interact with it, and sometimes alter country, which I find rather fascinating. So look, I will finish there and open for questions. Thank you.